Hi guys, it's Jason Wampler with another episode of The Rocket Minute. I hope you can hear me okay. Anyway, I just wanted to go ahead and finish up this launch control unit, and kind of wondering, I sure wish I could see this phone screen in daylight. It's a very limited phone. It's a cheap phone. I wouldn't recommend getting one. This guy right here, I can't see what is it. I'm looking at this guy right here. Is our little launch controller. I haven't really made any progress on it, but we are going to. Now the first thing we're going to do is strip us some good old-fashioned wiring. That was lunch. I'll finish it later. Need a cutter for that, and it is a DC powered launch controller. It's what's called a through box. Basically, the battery comes in. Battery comes in one side of this physically separated switch. When the battery comes in here, the launch controller. How do I say it? The extension wiring that leads to the electric match, that comes in, that goes out here. This basically goes to this interrupter switch, and in the off position, it does not have continuity that goes to the switch. In the on position, it does allow continuity to go to the switch. It sends power through the wiring from the battery to the switch, through this switch to that outlet, and of course ignites the rocket motor's electric match or igniter. Turn it off and it breaks contact and opens the circuit so the electricity can't connect. This is a DC powered through box only. It's a single function box only. I built much more complicated launch controllers. I don't do that anymore. It's not because there's no market for it, but I have to start somewhere. I have to learn how to run, or learn how to walk before you can run. Not to mention the fact my budget is limited. Speaking of which, hit the like, hit the subscribe, leave a comment. Nobody's leaving any comments. I can't believe that nobody's not fascinated on model rocketry. But oh well, this is the world is. Anyway, okay, so here what we're going to do, we're going to load up these switches. This is a 2-wire extension cord, and folks, I've said this before, and I'll say it again. If this stuff is, if this is an AC power cord, if it's set up to handle alternating current at between 93.7 to 120 volts, it will easily handle any type of DC current between 6, 9 to 48 volts. That's no big deal. DC voltage can still kill you. However, AC voltage is a guarantee that it'll cause your heart to explode for any period of time you're exposed to it. DC voltage is dangerous. AC voltage is dangerous. Use your head. Okay, be careful. You're dealing with electricity. When you're wiring this, you're not hooking it up to a battery yet. I could have possibly included an internal battery, but the problem is there's no room in this box. So I'll make another one I call the self box. Put 4 9-volt box batteries in it. Wire them in series, wire them in parallel. You have the same 9-volt, but all the amps. I'll hook that to an on-off switch. Put a light, a buzzer in it, 50 feet of lead to the igniters, and that's it. And that's an independently controlled launch control box. I suppose I can build one of those too. When I get done with it, I can keep it, or I can sell it on Mercari. I don't think Mercari. Yeah, Mercari. And if I'm done with this and I don't use this, I'll do the same thing. I'll sell it on Mercari. However, I like to keep this because, exciting news, we're going to be finishing up on that student #1 rocket. We'll be ready to launch that in a couple months, possibly sooner. So let me start by stripping the insulation, because we want the wiring out of this 2-wire extension cord. We're going to use it for DC power. It will work just fine. Folks, you can look on Craigslist free stuff. Sometimes people give away old vacuums, old household appliances. You cut the extension cords off, you cut them open, you use the wiring from that, the green, the white, and the black, which is power, is live, is black, white is neutral, and green is ground. You just separate all those wires, wrap them up, go to 99-cent store, get yourself a couple bags of zip ties for 99 cents each, and just make yourself rolls of 16 gauge stranded copper wire that way in 3 different colors. It's that simple. And guess what? You've only spent $2 and probably about 1.5 gallons of gas to go get this stuff off of Craigslist free stuff. So there's a way to do it. It's actually better and a lot less expensive than a traditional method of going out and buying all new, brand new components. I'm not entirely sure why the aerospace industry is so hung up on making everything as expensive as they possibly can and taking routes of manufacturing that are absolutely positively as labor intensive as possible. But I understand that, sometimes you need to take your time. When you're building a booster, a solid fuel booster, yeah, you have to take your time, and the chemicals will be expensive, but some of this airframe stuff, sourcing out the parts, the stuff is ridiculously expensive, especially fasteners and mechanisms. You say the word aerospace, and all of a sudden the vendors jacked up the price by 200, 300, and 500%. There's no reason to. So that's just boils down to human greed. So if you're also a process engineer, you understand the soundness and economy of getting stuff that'll do a very good job, but getting it from another source and getting it off of something that did not have that same dedicated purpose of serving in a rocket launch controller. This stuff will work just fine. Extension cords for vacuum cleaners, extension cords for belt sanders or drills. Unless the stuff is more than 60 years old, this stuff never goes bad. It has no need to. Extension cords are so highly evolved technically, they don't need to be re-engineered. They're perfect just the way they are. They last forever. So no need to be spending money on DC wiring. They know you're in a DC wiring project. The stuff is limited manufacturing run. It's expensive to make. Sure, it'll do the job just fine, but would you rather spend no money at all instead of 50 or 60 or 70 bucks at your local electronics store getting stuff that you could have substituted for wiring and switches that are rated for AC rating to last longer and work better? I spent $15 on a DC switch one time, and the damn thing broke within 2 days. $15 for something that breaks only 2 days. I had a very, very, very difficult time getting it replaced. I remember that. It's just terrible. DC switches are not built up. They don't last. They last a couple months, or maybe at the most. AC switches, these have to be built ANSI and OSHA standards. They have to be tough. They have to last up to 20 years. They have to. And they're so mass manufactured. The housing boom in California means this stuff is being mass manufactured, pennies on the dollar. This switch, this on-off switch, this AC on-off switch, I ripped off the tang for the grounding tab. This switch cost 90 cents. Now you go get a DC switch that does the same thing as this, it's just as rugged. Well, them folks got gold dust fever. You're going to throw down $10, $11, $12 for a 50-cent part. Something like this probably costs between 10 to 25 cents to produce per unit. So, and then they mark it up twice. I understand it. You get its DC equivalent, costs the same if not less to produce, and it gets marked up to $10. There's somebody out there getting really wealthy off of other people's ignorance, but it's not me. And I'm not getting wealthy, and I'm not ignorant. So I'm not buying into this baloney. I have an understanding of what is and isn't value added. If I don't like something, if I don't think it's worth it, I'm simply not going to buy it. I'll look for an alternative. So, greed does have its price. Okay, so how are we doing on time? So that's my soapbox lecture. No, I'm sorry, folks. get a little anxious about, you know, where their next meal is coming from. COVID-19 and the depression in the economy. Yeah, it's hard all the way around. Job market's still there, but you know the thing is, people are looking to save money. I'm not really one to buy into this baloney about stoking the furnaces and supply issues. Get your act together, start supplying the parts. I suspect that we don't buy, this country doesn't buy anything from China anymore because of the interesting goings on in the Ukraine and Russia. China can't make up its mind. They have 1 foot in and out of the water. They want to be trade partners with the United States, but they want to be allies with the Russians. So I don't know, it's a crazy world. And these retailers, they want to piggyback on the supply chain issues and use that as an excuse, play around with the consumer public's patience. You know, I saw a coupler that was basically about 2.5 inches long, and then I saw one that was almost 3.5, 4 inches long. The price difference, the one was, the smaller one, of course, was 55 cents. The larger one was $2.60. Where's the extra money go? So anyway, that's just me. Okay, so we've cut side of this extension cord down lengthwise. Believe you me, there's more extension cord to go around than meets the eye, and there's absolutely ever going to be needed in the next 1,000 years. You're not killing off an endangered species. Don't worry about it. So this has 2 wires. Now, again, as mentioned earlier, AC power usually flows to a house at 60 hertz, 15 amps, and 110 to 120 volts. Smart homes, I believe, smart homes have 115 volts going to them, still at 60 hertz, definitely at 15 amps. A lot of GFCIs and USB and cable outlets that all have their own microprocessors. I'm talking about the little outlets and switches in the walls. It's a smart home. It runs delicate electronics. The problem with electronics, they wear out within 5 years. The home will be standing for the next 50, so you're going to have to do some retrofitting. But AC voltage is very, very powerful. Now, DC voltage is not as powerful. You can still do some damage with it. But the point is, as mentioned before, this stuff is plentiful and cheap. There's so much of it that nobody wants. You can drive through downtown LA, find somebody who parked a vacuum cleaner on the side of the road, go pick the darn thing up, take it apart. You've got a couple of electric motors, some plastic gears and bearings, a movement control board, and a switch, and plenty of this stuff. You can cannibalize stuff that people don't even want. So I recommend Craigslist free stuff for anything that might, you know, help supply your efforts to scratch build rockets, launch controllers, and such and so forth. I think after we master launch controllers, I am going to show you how to make electric matches, which are basically the electrically ignited electrical igniters, DC powered igniters. They have pyrogen at the end of them, but how in the world do you make the metal? How in the world do you make the metal glow at the end of at the tip of the igniter where it goes into the motor? There's a trick to that. If you know Ohm's law, laws of resistance, and a little bit about electricity, I'll show you. But right now, we've been putting this project off for too long. It's been about a month and a half. We need to get it done, so that's what we're going to do. Okay, now I know what I was saying. AC electricity, black is always live, which means that's where most of the power is coming through. In any home that's more than 50 years old or around 50 years old, you pull off the wall socket. If you fail to open up the circuit breaker and open up the circuit, keep power from flowing to the live black wire, you're going to touch it. It doesn't matter if there's a whole length of exposed wiring. You just touch the ends. You touch the 2 ends of these wires. The white is neutral. The black is live. You touch those two, it's basically going to feel like somebody slapped you in the side of the face. Really, really hard. It's very powerful. 93.7 volts is what you're going to get here. If it's a 110 or 120 house, if it's a 220 volt outlet, industrial warehouse or workshop, 220 volts. Sometimes that's needed for larger equipment. Then you definitely don't want to touch that, because that'll knock you on your ass. It'll throw you backwards about 5 feet. You'll go unconscious for about a half an hour. You may or may not wake up in the hospital. AC electricity is not something to be fooled with. But, like I said, black is where the power is, and it needs this neutral. So black is live, white is neutral, green is ground. But the thing that AC power and DC power both have in common, you need ground. So I'm not entirely sure the dynamics of how the ions flip and flop back and forth. There are a lot of graphs and charts. There's sine, cosine. There's math that explains electricity. If you learn from math, which 99% of the world's population does not, then you can understand it. I think there's an easier way to explain things. I just haven't figured it out yet. So in AC power, black is positive, white is neutral, green is ground. Well, this particular extension cord has these two wires in it because it didn't need the ground. It just ran a very small component. Doesn't draw a whole lot of amps. It's not going to be redirecting the voltage and amperage to a point where it's going to be drawn so much that voltage is going to be looking for another source of ground outside the drill or the vacuum cleaner. You suspect that at any time, though it is, it's a large household appliance that runs off electricity. Even if it doesn't come with the ground, you want to prevent shock hazards. Find a way to ground the component and hook it up with the ground that comes to the house's wiring. That's just a safety tip. It's not fun being shocked either. It's very unpleasant and uncomfortable. And it'll freak kids out too, so don't do that. Okay, the reason I'm going on this mad verbal tirade is, as mentioned before, black is live, white is neutral, green is ground. That is AC voltage. We're not dealing with AC voltage today because we're building a through box. Battery over here goes through this box. This switch connects the wiring through the outlet, and that goes to the igniter. It's a through box. So basically, DC electricity goes through it. I just call it a through box because I'm a designer and engineer. Okay, so what do? So I've told you guys, I've talked you into getting AC wiring out of an extension cord. This basically cost me nothing at all, and it's perfectly good. There's nothing wrong with it at all. Well, here's what you do. You make a decision, and be careful about the decisions you make. In this case, because black for DC voltage is ground, then you might want to consider just making black your ground wire, or negative wire. Be careful. The white wire is usually neutral, didn't have power going through it for AC voltage, but since it's a sharp contrast to the ground wire, which is black in DC voltage anyway, you might want to consider making black neutral and white the positive. The colors, they just identify the polarity of the battery. They keep you from miswiring these launch controllers. Here's the catch though. If black is power, you want to stick traditionally to the black being power wire. Be very, very careful. You're going to break something. Okay? Keep in mind that if you have an interrupter switch in here, the whole time you're going to be looking at the black wire, you're going to have to keep reminding yourself this is DC power, because AC power is basically the same exact thing. I kind of did that one time. I messed up on the wiring. I ended up having to take the wiring out and completely strip down a 4-channel launch controller I was building because I lost my place. And I got confused. I couldn't remember. Did I want to make the white positive, or did I want to make the black positive, so we could show that DC power and AC power are related, both use the black wire as power. So my strongest suggestion is to go ahead and use the black as ground, use the white as positive. Get us as close to black and red in DC power as you're going to get. So, and here you go. I'm stripping and grooming these wires. Now, what next am I going to do? Well, I'm going to do a lot of things. This may not be long enough, but that's okay. Now we're going to figure out exactly how we're going to wire this up and the position we're going to put this in. Right now, I need to take a break, so we're going to go ahead and conclude this particular video. This is part 1. I'll come back and we'll do part 2 in about 15 minutes. Thank you very much.